So we're going to be looking at factoring, okay? The key phrase when factoring polynomials is that you're going to be factoring completely. Always check to make sure if you're done or not, if you can do anything more. Remember, these are all the factorings that we already know how to do. The order I want you to check for, first, greatest common factor. Always check that first. Second, I want you to check and see if it's a difference of two squares. Third, then we'll just resort to that normal trinomial factoring where we use the x. All right, let's get this a little bigger. All right, so looking at problem 1, the first thing we're going to look for is common factor. Okay, so I know 7 is a factor of both of these, but I'm going to need to check the 98. So 98 divided by 7 is 14. So the greatest common is 7. And remember, we take the smallest exponent, so x cubed. And that's my common factor, the greatest common factor. Then I'm going to divide. So 14x to the 5th divided by 7x cubed gives me 2x squared. 21x to the 4th divided by 7x cubed gives me plus 3x. Negative 98x cubed divided by 7x cubed. Negative 98 divided by 7 is negative 14, and the x cubes cancel out. Okay. Now I turn my interest inside the parentheses, and I'm going to factor again. They have no common factor. They are not a difference of squares, so I'm just going to use this. A times c, 2 times negative 14 is negative 28. What are the factors of negative 28 that add to 3? Positive 3. So positive 7, negative 4. Okay, so when I go, I keep everything together. 2x squared, I'm going to have to put 2x times x. These two spots are going to multiply. So whatever I'm going to put here is going to be one of those two factors divided by 2. So I'm going to divide the negative 4 by 2, and I put a negative 2 right there. The other spot does not have a coefficient to divide by, so I'm just going to put a positive 7. Now I've factored completely, and this is my final answer. Okay. Again, key phrase, completely. All right, looking at number 2. First thing I always look for, greatest common factor. So we've got 2x to the 4th. Okay, when I divide here, I'm going to have x squared. Divide here, negative 9. And I'm going to look inside the parentheses. They don't have any common factor. They are a difference of two squares. So, keeping everything together, I'm going to factor the parentheses. X times x gives me x squared. 3 times 3 gives me 9. Difference of squares has 1 plus, 1 minus. And I'm done. That is factored completely. All right. All right, let's look at this last one on the front. Greatest common factor first. It's going to be negative 3x to the 5th. Okay. Remember, every time you pull a factor of the negative out to the front, it's going to change every sign inside the parentheses. So here, when we divide, we're going to have x squared. Here, when we divide, we're going to have negative x. Negative 48 divided by negative 3 is positive 16. And the x to the 5ths cancel out. Okay, now I look inside. No common factors, not a difference of squares, so I'm just going to do my basic factoring. What are the factors of 16 that add to be a -1? Don't think I have any, do I? Factors of 16 that add to be a -1. 1 and 16, 2 and 4, sorry, 2 and 4, 2 and 8, 4 and 4. I'm done. Nothing else I can factor. Okay? All right. Okie doke. So you always have to follow up to see if you can factor, but no, I don't have anything there. Okay? All right. If I was finding the roots for this, I would resort to the quadratic formula, right? But for factoring, I'm done. All right. So on the back, we've got some new forms of factoring, okay? When you have a difference or a sum of cubes, this is my sum of cubes right here because 2 cubes are adding. This is my difference of cubes right here because the 2 cubes are subtracting. So it's just a formula. You figure out what A and B are and you just plug it into the formula. Okay? The sum, where it has a plus here, it has a plus and then a minus. The difference, where it has a subtract here, you have a subtract and then a plus. Okay? All right. So the trick is figuring out what is the cubed value, rewriting the equation or the statement to where it shows some number being cubed. So if I look at 8x cubed, I have to be able to think it through. What number cubed would give me the 8? 2, right? 2 times 2 times 2 equals 8. So I'm going to rewrite this as 2x cubed. What number cubed would give me 27? 3. I'm going to rewrite this as 3 cubed. So A is inside the parentheses, 2x, and B is inside the parentheses as 3. Okay, so this is a difference. I'm going to be using this formula right here. All right, so I'm just going to fill in with the A and the B. So this is what my factoring is going to look like. Okay, so I've got parenthesis A minus B, close parenthesis, times A squared. 2x times 2x is 4x squared, plus A times B. A times B is 6x, plus B squared. 3 times 3 is 9. And you're done. You don't have to do anything more than that. You're just plugging the numbers into the formula. The part that makes it a job is just finding what number cubed can I replace inside those parentheses. What number that would be cubed will I put in there? So if I look at number 2, I'm going to rewrite this as parentheses cubed plus parentheses cubed. What number cubed gives me 64? 4. And then x. 4x cubed gives me 64, x cubed. Look at the next parentheses. What number cubed would give me 125? 5 cubed is 125, and a y. 5y cubed is 125y cubed. So A is 4x and B is 5y. This is a sum, So I'm going to be using this formula. All right. I'm going to put my fingers here so I can keep track of it. So we're going to have parentheses 4x plus 5y. It says a plus b. Okay. New parentheses. It's a little smaller so you can see the whole thing. A squared. 4x times 4x is 16x squared. Minus a times b is 20xy. Plus b squared. 5y times 5y is 25y squared. Okay, just plugging in the numbers you find into the formula. All right. The next thing we're looking at, we also have not seen this factoring unless you did it in algebra. Some teachers do use grouping when they're factoring. So grouping, it does not really matter what order these are in, but we like to keep them in descending order, just for habit. I'm going to break off the first two pieces in parentheses and the second two pieces in parentheses. Looking at just the first parentheses, what do they have in common? What is their greatest common factor? It's going to be x squared. Factor that out of just that first parentheses. So we're going to have x minus 3. Okay. Then I've got a plus. What do the next two numbers have in common? 7. Factor that out of only the second parentheses. So we've got 7x minus 3. All right. These parentheses will always match. If they don't match, either you've made an error or this is not factorable. Most likely, you've made an error. Okay? So these have to match. And when I go to write my two parentheses for factoring, the outside numbers come together in one parentheses. So x squared plus 7. And the inside makes up the second parentheses, x minus 3. Okay? It's just represented one time, okay? Just represented one time, but these have to match. All right, let's look at the next one. Pick the first two and the second two. Okay. So we're going to look for greatest common factor here. We're going to have 2x cubed. Inside the parentheses, we're going to have x squared plus 6. Okay. Then I've got a minus between it. What do these two have in common? 5. So we're going to have 5 times x squared. Anytime you have a minus here, it's going to change all the signs. If I divide negative 30 by negative 5, I'll have a positive 6. These two have to match. If they don't match, you made an error. Probably that sign right there. So when you go to write your answer as two parentheses, the outside comes to the first parenthesis, 2x cubed minus 5. And the inside is the other parentheses. But only once. It's only represented one time. Okay, so remember when we FOIL, we're going to take the 2x and we're going to multiply by the whole parentheses, right? Then we're going to take the negative 5, and we're going to multiply by the whole parentheses. So by factoring, by grouping, what you're taking advantage of is